Hello there! Welcome to my channel, and today we are going to be talking about GitHub workflows for Azure Static Web Apps. If you're joining me here today, then I'm guessing that you're working on chapter 15 of my book, Beginning Azure Static Web Apps for Blazor, the second edition, and you're looking for some clarification because chapter 15 is quite dense. In a previous video, we already talked about setting up what permissions and information we need from the Azure portal into GitHub to make our workflows work. And today we're going to be looking at those workflows, explaining what goes on inside of them so that you have a better understanding of what is there. And here you can see we are inside of GitHub. I am using the repository that goes along with the book, so you can copy the code directly from here. Chapter 15 shows the end state of chapter 15, which means at the beginning of the book, at the beginning of the chapter, there's going to be a couple of little differences, but I'll explain them as I'll go along. The first thing we need to look at is in the GitHub workflows, we have three different files. We have build and deploy, iac.yaml, and custom domain. We're going to start with the IAC, infrastructure as code. This is what's going to create our Azure Static Web App, and it's what's going to set the environment variables that we rely on in our .NET code in order to access resources both inside and outside of Azure. Now, before we look at what the actual workflow does, let's take another brief look at the structure of a workflow. We start off with our name. This is the human readable name that will be displayed inside of the actions page in GitHub so that you can see which workflow is running and know which one to select. Then we have our on flag. This is how the workflow gets triggered. We're using here workflow dispatch. That means that we can manually run our workflow. But there are also triggers so that you can run it when making a pull request, when you are changing something in a particular branch. It's outside of the scope of these books. It's well worth looking into, though. You get a lot of control here. We're using workflow dispatch for this particular pipeline because our infrastructure isn't something that we expect to change on a regular basis. So we want to run this manually on those rare occasions where we need to. We're not going to be running this every time we redeploy or every time we change our workflow. Then we need the permissions for our workflow. First up, we have an ID token permission, and we want to be able to write to that ID token because we need to log into Azure. And second, we have a contents read permission, and that is because we need to get access to our repository in order to get the files needed to run and deploy our application. Next, we have our jobs section. Now, we only have one job in this workflow, but in other workflows, you'll see that we have multiple jobs. So knowing that these are the smallest building blocks that you can rerun at will is important to know. So when we create our static web app, it's one block. We don't need to split this up. In the last one that we'll look at today, our build and deploy pipeline, that's going to be different, but we'll save that for them. So to create our static web app, first of all, we are going to run it on the latest Ubuntu. We're going to be running this in a Linux pipeline. Why Linux? Because it's generally the most performant and efficient agent that you can run on for doing a lot of things. Not for everything, of course, but this is the one that I generally default. Next up, we need to check out our code because we have files in there that we're going to need to read in a second. And after that, we're going to log into Azure. Now here we're using those client IDs, directory IDs, and subscription IDs that we got from the previous video. This is how we identify ourselves to Azure. Once we've logged in, we can actually do the real work. So we're going to be using the Azure CLI here. And the first thing we're going to do is say that, hey, you can install extensions if you need to. And as this is running inside of an action, you can do that without asking for a prompt because no one's going to be here monitoring that. We need that because using some of the commands that we're going to be running requires an extension, or at least it did when this was written. And so we want this to happen without it. Next, we create our resource. Now, we have this resource group inside of the variables. We set those up in the last video along with our Azure region. An important thing to know here is creating resources in Azure using AZ and bicep files that we're going to be coming up to. It is idempotent, which means that you can run this multiple times and it's always going to end with the same result. So if you run this twice, it's not going to break anything. After we've created our resource, we want to deploy to our resource. And we're going to be doing that by passing in the SWA name, which we also set up in our variables, and by calling our main.bicep file. This is where we're going to specify the resources that we want inside of Azure. So let's find those on this side. We have somewhere in here, we have our main.bicep. Okay, so inside here, we are setting our location. Now we can have this as a parameter, but we are defaulting it to the location of the resource that we're running inside of. Next up, we have our name. We don't default this. You always have to pass the name into this template. Otherwise, it's going to break on you. And finally, we're passing in our SKU, our SKU. If you don't enter anything for this, we're going to be using the free version, but you can override it if you need to. And after that, we have the minimum amount of code that you need in order to create an Azure static web app. All we need is a name, the location, and the SKU that we're running. There are a lot more controls that you can have here. And although it's out of focus for this particular video, I would recommend looking this up using MS-Learn because you can have a lot of control here to do the things that you need to do. Back to our pipeline, I just want to point out that here we're actually overriding that SKU. We're overriding it with the standard tier. That is the paid tier. That is because in the following video, we're going to be looking at custom authentication. And for that, you need the standard SKU. At the beginning of chapter 15, this will still be the free tier. You will change it later in the book. Once we have our static web app, then we need to set those environment variables. So the first one that we need is our Cosmos DB connection string so that we can read and write our blog posts. And then again, for the custom authentication in the next video, we are going to need a client secret and a client ID. That is still to come. We're going to run these now, but it's not going to do anything if you're at the start of the chapter. The next workflow that we look at is a lot more complex, I'm afraid. And that is for running or for setting up our custom domain. So first of all, again, this is going to be a workflow dispatch. You're not going to change your custom domains very often, probably even less than you are going to be changing the environment variables in your app, which is why these two are split up. Again, we need an ID token so that we can log into Azure, and we're going to use the contents token. We are running this again on Ubuntu latest, same as before. All of the workflows that we're using are going to be running on that. And then we just have some information that is specific to this one workflow. And that is the DNS and the domain name. I didn't make this a variable just because it's only used inside of this workflow. As you can see, the SWA name and the resource group, that is coming from that same variable as the first workflow. And that is the point here. We don't want to have to retype things that are shared between workflows. It leads to issues should you mistype something. And it's easier to change in the future as well if you need to. Then we have our steps. This again is all one workflow, but we have a lot more steps included in. First of all, we log in with Azure again, the same as we did before. Then we need to get the host name of our Azure static web app. So you can see here, if I bring this across, we are using this AZ static web app environment list. This will get every single environment that we have inside of our Azure static web app for this static web app name in this resource. And then we're going to query that. Just get rid of my thing down there. And what we're looking for is the default name for the environment. That is our production environment, which is what we need for our custom domain. And we're taking out of that the host name and storing it, if we go back to the beginning, inside of this SWA host name. And then we're adding that to our GitHub environment variable so that we can use it later on. Then we're going to create the www CNAME record so that we can access our www URL. First thing we need to do is check, does one actually exist already? And if we have one, and the one that we have matches our host name, we don't need to do any setup here. We can skip the rest of this step. If not, then if we have a current name, then we know that we need to update it to be the new domain name. It's currently pointing at the wrong place. However, using AZ Network DNS record, there is no way to update at the moment. What you have to do is delete and recreate it. So that's what we're doing here. We are deleting the existing record. If we don't have any current name, then we just know that we need to create it, and we'll just output something saying that. Then we use the network DNS record set CNAME for the type of record that we want, and set record. And we're going to update it with our new information. Then we need to repeat the same process for our alias record for the APEX. First of all, we check to see whether or not we have one. After that, does it target the same resource ID that we're using? And if it does, then we're finished. We can skip to the next step. If it doesn't, then again, we need to delete that record. And finally, we can recreate it. That's setting 2 of the 3 DNS records that we need. The next has to wait a little bit. Now we're going to tell our static web app that for our static web app in our resource group, we want the host name to be www.ourdomainname. And that will set up inside of Azure Static Web Apps the custom domain so that when the DNS group sends the information to the static web app, it knows it can display it. This can take some time. First of all, it has to update the static web app, and then it has to validate that it actually is allowed to use that domain in order to accept content. Because we don't want to wait for that to happen, we use this no wait flag at the end. That just means that all the validation happens in the background. We will just move on to the next step. And that next step is the validation that we need for the Apex hostname. That doesn't work, as mentioned in chapter 14. That doesn't work using the domain name as the information inside of the record. Instead, we need to get an explicit ID out of the static web app and set that inside of a TXT record. Before we can get that token, we have to tell the static web app to actually try and access it. Unfortunately, it's a little bit chicken and egg here. Before you can set the record, you need to tell the Azure Static Web App to use it, but you can't set the record until you've told the Azure Static Web App to do it. So what we're going to do here, we are going to, again, set for our static web app in our resource group for the main Apex domain, a validation method of DNS TXT token. And then we're going to say, don't wait. 1, because this takes time to create the token, and 2, because the validation is going to fail even if it didn't take a long time. Once we've done that, we're going to loop through various checks to see whether or not that token is available. So we're going to use the AZ Static Web App hostname show in order to get out all of the information for our hostname, and we're looking for a validation token. This may or may not exist because this takes anywhere between a minute and more than 30 minutes to generate. So if our token's retrieved, then we're going to break. We're going to come out of our loop and continue. Otherwise, we are going to say that the token's not ready yet. We're going to sleep for 5 minutes, and then we're going to try again until we hit our maximum attempts, and then we're actually going to exit with an error saying, we didn't get a validation token, try running again. This workflow is also the same as the previous one. You can run it twice, it won't break anything. So if you run it the first time and it takes too long to generate, you can always run it a second time. It won't create a new token, but hopefully it will be available for you at the end of the second run. This works for me about 99% of the time. It's there fast enough, generally within 5 minutes, sometimes up to 20. It's very rare that this fails for me. Once we have our validation token, we add that to our GitHub environment as well. And then we set up our record inside of the Azure DNS. Now, text records work different to the CNAME and alias records. Whereas for the alias and CNAME, you can only have one record per Apex domain for the alias or per CNAME. For the text records, you can have multiple. So whilst we can still do the existing check, if it exists and it's got the same value as our token, then we can skip. We don't need to do anything. If we do have existing tokens, we can't delete them as we did with the CNAME and the alias. All we can do is just let the user know that, hey, you have tokens here. I don't know what they are, so I don't want to remove them, but you might want to investigate it. And after that, we create our new text token, and again, also give an extra warning to the user again, hey, you've got multiple text tokens. You might want to know about this. This sets up the custom domains. Doing this will set up our custom domains and get them to work. Then we move on to the last, and that is the build and deploy YAML file. It basically does what it says on the tin. We are going to build and deploy our application. Only now you see we have quite a different on here. When we do a push to our main branch, except for our other infrastructure as code files, because we don't need to rerun this when we change those, or rerun on pull requests against main that are opened, synchronized, reopened, or closed. This is how we can create those same staging environments that the Azure GitHub action does for us out of the box. Then we need to give it our permissions. Again, the ID token, because we need to log into Azure. The contents, because of course we need to be able to read our repo. And we need this pull requests write token, which, as I explained at the start of the book, is something that's missing from Microsoft's current pipeline that you get out of the box. But you need this because of a change in GitHub security. And without this, you cannot actually update your pull request with the location of your staging environment. The first job that we have is build and test. So if we are pushing, or if we are on a pull request that is not being closed, then we want to check out our files. We want to set up .NET version 9, because at time of recording and time of writing the book, .NET 10 wasn't supported for Azure Functions inside of Azure Static Web Apps. You could, of course, use both. You could use 10 for the Blazor app and 9 for the functions, but I'm just keeping it simple here and using 9 for everything. Then we publish both our client and our API to this dist folder, and that's so that we can use it in the next stage. So far, most of this is what you do out of the box with the Azure action. The next one is the fun one. You can now run any tests, static analysis, or anything else that you need to do to your code before we move further. So you can run your tests, you can fail on a test fail, you can fail on issues with a static analysis, and it just ensures that you have more protection moving forward. And then finally, we need to publish these files up to an artifact. We're pushing everything in the folder of dist. So that's both our client and our API in one artifact. We are including hidden files because without that, our Azure function will not deploy correctly. And we have a retention days. We're using 1 here. This is something that you're going to need to find for yourself depending on your workflow. If you are doing continuous integration and deployment, chances are 1 day might be enough for you here. If you're not deploying daily, then you might want to up it to a week, 2 weeks. Just be aware that the longer the retention, the more artifact space you'll use up inside of your subscription, and at some point you're not going to be able to create new ones. Once the artifacts are uploaded, then we are done with this job. Then we can move to our deploy phase. This is exactly the same. We push to main, or when a pull request is not being closed, we run this job. We check out our code again, same as we did before, and we download those artifacts that we just uploaded. Now you might ask, well, if we're uploading them and then immediately downloading them again, what's the point? Why do I need to do this? And the answer is that when I was talking about the IAC pipeline, I said that the jobs were the smallest things that you could rerun. If you upload your code to an artifact, then that means that if you run the branch or the pipeline again and you deploy something else and it breaks production, you can go to a previous deploy and you can rerun the deploy job against the artifacts that it created. So you can always go back to a safe version if you were inside of that window where the artifact lives. That is one of the huge advantages that we get with doing it this way, rather than what you get out of the box with the Azure functionality. Next, we're going to log into Azure again because we're going to be using the CLI for this. And what we're using the CLI for, first of all, is to get the token from our Azure Static Web App. When you run using the out-of-the-box workflow, the token is something that is written to your secrets by the Azure portal. However, because we are creating our Azure Static Web Apps on the fly here, we don't have that ability to hold the secret inside of our repository. And to be honest, we don't want to. So instead, we will just read that secret every time we do a deploy. We will add a mask to it so that you never put your secret inside of your log files. And then we will add that to the GitHub output so that we can use it in following step. Next, we need to know the environment that we are deploying to. Are we deploying to production, or are we deploying to a staging environment? And we do that by checking the event name. If we're pushing, then we know we're deploying to production. If it's not a push, then we know it's a pull request because that's the only two options that we have. And in which case we need to make an environment name that we can easily recreate. So here we're making staging and then the event number, which is just the PR number that we have. So this will always be the same for every PR that we run against this workflow. After that, we need to install Node, which might sound odd because we're deploying .NET code. But we need Node because in order to deploy an Azure Static Web App, we need access to the SWA CLI. This can't be done using AZ Static Web App site yet. So that's the next thing we're going to install. And after that, we can actually then deploy our application. We're setting the resource group and the app name as environment variables, and we're setting the non-interactive. The reason why we set this to true is the same as we did the no wait inside of the custom domain flow, because no one's going to be looking at this. You can't interact with the console, so it just needs to go straight through. And then we are deploying our application using the deploy config, which you will find inside of the CLI config JSON, where we set the location of our application, the location of our API, what API language we're using for the Azure function, .NET isolated here, the version number, and the last one we're not going to be using, but it was in there anyway. And as well as that, we also use the app name, the resource group, and we give that secret token that we had to make sure that we can deploy successfully. Oh, we also say which environment we need, of course. Can't forget that one. So this is where you'd either have that production or staging 1, staging 2, etc. For the production flow, this is the end of what we need to do. We don't need to go any further than. For our pull requests, we want to update our pull request the same way that the out-of-the-box workflow does. So when we are on a pull request, so not for pushing to main, we need to use that AZ static web app environment list that we've used in a previous workflow. And we need to get the host name that contains our environment, because the host names will always contain the environment that they're deployed to inside of an Azure Static Web App. We add that to the output, and then we update the pull request using GitHub script. First thing that we do is make a markdown text just with whatever we want to put in there. So we have a link to where you can test, and I've just added the person who kicked off the workflow inside of this as well, so that you know that who forced the last run of the workflow. And then we use GitHub REST issues create comment, because every comment on a pull request is classed as an issue comment. We pass in the issue number, the PR number, the repo owner and the repo, and the body is just going to be the text that we created. That will add the comment to our pull request, allowing us to click on it and launch our staging environment for test. The final job that we have, when you have completed your testing, whether it works or not, we need to clean up our environment still. So this one only runs for pull requests that are being closed. This is our cleanup job. First thing we do is we log in with Azure, and then using the AZ static web app environment, we delete our staging and then the GitHub number environment. This might seem a little bit odd because we're using the SWA CLI to deploy, but the AZ static web app environment command to delete. Unfortunately, at the moment, that's just the way it is. You cannot do this any other way. I hope that changes in the future, but for now we need to use both tools in order to get this done. So that is how we can use workflow files in order to deploy our application, to create it, to set up our custom domains. There's a lot of information to get through. I hope it's clearer in the video if you needed help from the book. If you have any other questions or comments, you can either contact me on Blue Sky, my link will be in the description, or please comment on this video and I will do my best to help you and answer any questions or fix anything which I got wrong inside of the video. Thank you all, and I will see you in the next video where we're going to be talking about adding custom authentication to our Azure Static Web App. See you then.